Hi, I'm Mr. Parker and this is question 7 on the OCR MEI Core 4 paper from June 2012. For more questions on this exam paper, click the link here or check in the video description. Question 7. Figure 7a shows the curve with parametric equations x equals 2 cos theta and y equals sine 2 theta for theta between minus pi over 2 and pi over 2. The curve meets the x-axis at O and P, and Q and R are turning points on the curve. The scales on the axis are the same. In part 1, it says state with their coordinates the points on the curve for which theta equals negative pi over 2, theta equals 0, and theta equals pi over 2. All we have to do to find the coordinates are substitute in our values of theta to our parametric equations for x and y. So when theta equals negative pi over 2, x is going to equal 2 cos theta, so that's 2 cos negative pi over 2. Cos negative pi over 2 is 0, so 2 lots of 0 will still be 0. For y, we've got sine 2 theta. If theta is negative pi over 2, 2 theta will be negative pi, so we're trying to work out sine of negative pi. Sine of negative pi is also 0, so the coordinates at theta equals negative pi over 2 are 0, 0. When theta equals 0, we get x equals 2 cos 0, which is just 2. For y, we get sine 2 times 0, so just sine of 0, which gives us 0. So the coordinates are 2, 0. When theta equals positive pi over 2, we get x equals 2 lots of cos pi over 2. Well, cos pi over 2 is 0, so 2 lots of 0 is 0. And y equals sine 2 multiplied by pi over 2, so sine pi, which is also going to be 0. So the coordinates at theta equals pi over 2 are 0, 0. In part 2, we need to find dy by dx in terms of theta, and then hence find the gradient of the curve when theta equals pi over 2 and verify that the two tangents to the curve at the origin meet at right angles. In order to find dy dx, we're going to think about the chain rule. And the chain rule says that if I want to find dy by dx, I could find dy by d theta and then multiply that by d theta by dx. Notice here it looks like the d thetas cancel out. We'll start by finding dy d theta. We know that y equals sine 2 theta. You could use the chain rule to differentiate this, but it's fairly straightforward, so I'll do this informally. If we want to find dy by d theta, if we differentiate sine, we get cosine, so here we will get 2 cosine 2 theta. If we want to find d theta dx, first it will be easier to just find dx d theta, that's just differentiating this here. So if x equals 2 cos theta, then dx by d theta will equal negative 2 sine theta. So to find dy dx, I'm going to use the fact that d theta by dx is just the reciprocal of dx by d theta. So I get dy by dx equals 2 cos 2 theta multiplied by 1 over negative 2 sine theta. So the 2's will cancel out and I get left with negative cos 2 theta over sine theta. Next, I need to find the gradient of the curve when theta equals pi over 2. We get dy by dx equals minus cos 2 theta. Well, if theta is pi over 2, 2 theta is just pi, so minus cos pi over sine theta, so sine pi over 2. Well, cos pi is negative 1, so negative cos pi is just 1, and sine pi over 2 is just 1, so we get 1 over 1, which is 1. Next up, we need to verify that the two tangents to the curve at the origin meet at right angles. Well, in part 1, we showed that at the origin, theta either equals minus pi over 2 or it equals pi over 2. And conveniently, we've just found the gradient when theta equals pi over 2. So next, we're going to find the gradient when theta equals minus pi over 2. We've got negative cos 2 theta, which becomes negative cos of negative pi over sine negative pi over 2. Remember, you can either use your calculator or the shapes of the graphs to find these out. Cos of negative pi is negative 1, just like cos of pi, so the top becomes positive 1. Sine of negative pi over 2 is negative 1, so we're left with 1 over minus 1, which is minus 1. So the gradient of the tangent at theta equals pi over 2, we'll call that m1, that's equal to 1. And the gradient of the tangent at theta equals negative pi over 2, we'll call that m equals negative 1. And you should know that for two lines to be perpendicular, the gradient of one of the lines should equal negative the reciprocal of the other line, which is true in this case. So we can say, therefore, the lines are perpendicular. In the last part, we showed that dy by dx is minus cos 2 theta over sine theta. So at a turning point, dy by dx equals 0, so we can say that negative cos 2 theta over sine theta must equal 0. If we have a fraction that equals 0, the denominator can never be 0, so the numerator must be 0, so negative cos 2 theta must equal 0. And if we multiply by minus 1, we would get that cos 2 theta equals 0. If you think about the shape of the cosine graph, that means that 2 theta must either be at pi over 2 or negative pi over 2, which means that theta must be plus or minus pi over 4. However, that gives us two turning points, which correspond to the fact that the gradient is 0 at Q and at R, and we need to figure out which one of these will be the one that we want at Q. Well, when theta equals pi over 4, the y-coordinate is sine 2 theta. 2 lots of pi over 4 is pi over 2. So y is sine pi over 2, which is 1. We could substitute in negative pi over 4, and we find out that y is negative 1. So the solution for q is when theta equals pi over 4, and the solution for r, which we don't want, is when theta equals negative pi over 4. Make sure you answer the question though. It's not asking us to find out what theta is, it's asking us for the exact coordinates of the turning point Q. Well, we've got the y coordinate here. All that's left to do is find out the x coordinate. So when theta equals pi over 4, x is going to equal 2 cos pi over 4. If you know your exact values for your trig functions, then you'll know cos pi over 4 is 1 over root 2. And if you multiply that by 2, you actually end up with root 2. So the coordinates are root 2, comma 1. Part 4 says express sine squared theta in terms of x, and hence show the Cartesian equation of the curve is y squared equals x squared bracket 1 minus a quarter x squared. So starting with x equals 2 cos theta, if we square both sides, we get x squared equals 4 cos squared theta. Dividing through by the 4 gives us x squared over 4 equals cos squared theta. And then if we use our identity sine squared theta plus cos squared theta equals 1, we can rewrite the right hand side as 1 minus sine squared theta. If we just rearrange this, we end up with sine squared theta equals 1 minus x squared over 4. So that's the first part done. We've expressed sine squared in terms of x. All that we've got left to do now is rewrite y squared in terms of this. So if we start with y equals sine 2 theta, and we use the double angle formula, we can rewrite sine 2 theta as 2 sine theta cos theta. And then if we square both sides, we get y squared equals 4 sine squared theta cos squared theta. And we know that x squared is 4 cos squared theta. So we can swap the 4 cos squared theta for an x squared. And we know that sine squared theta is 1 minus x squared over 4. Or, as they've written up here, 1 minus a quarter x squared. Finally, in part 5, it says when the curve is rotated about the x-axis, it forms a paperweight shape as shown in figure 7b. We need to find the volume of the paperweight shape. We know that using our formula for volumes of revolution, the volume is equal to pi multiplied by the integral of y squared with respect to x. Well, we know from the last part that y squared equals x squared multiplied by 1 minus a quarter x squared. And if we substitute that in, we get v equals pi multiplied by the integral of x squared multiplied by 1 minus a quarter x squared with respect to x. We need to know the limits to integrate between. Here we know that it starts at 0, and in part 1 we found that the coordinate here, where y equals 0, is 2. In order to make this more straightforward to integrate, I'm going to expand out the brackets to get x squared minus a quarter x to the power of 4. Integrating x squared gives me a third x cubed. And integrating a quarter x to the 4 gives me 1 over 20 x to the power 5. If you notice that substituting 0 into both of these terms here would give 0, we can just work out the first limit and we get pi multiplied by a third times 2 cubed. 2 cubed is 8, so that becomes 8 over 3. And 2 to the power 5 is 32, so that's 32 over 20 or 16 over 10. And if you simplify that either using a calculator or in your head, you get 16 pi over 15.